This computer. Okay, so hello, we're going to talk about using OSC today. And now we've already seen how to sign up for an account and how to log in to OSC. You can either use PuTTY if you're using Windows, that's what I use. You can use Terminal if you're using a Mac, or you can log on to the OSC on demand and use the terminal there. I will just go through signing in OSC on demand and getting to that window if we haven't done that already. Okay, so here's the link. It's ondemand.osc.edu. Sign in with your password. Okay, so this is what it looks like when we sign in. There's some information about OSC. Up here, there are interactive apps that you can use. RStudio is very useful. If now that you have an OSC account, you can use RStudio on OSC and you're going to have so much more computing power behind your R scripts. But we're not going to talk about that today. We're going to go to clusters. And here we have Owens shell access and Pitzer shell access. So these are two different login nodes that are available through OSC. You can use either one, I believe, for this class, but just know that they're going to have different programs loaded onto them. We're going to talk about modules. So you can load programs through these modules, and the versions of different programs will be slightly different depending on which shell you choose to connect to. So we click on one of those. This is Pitzer. It might not let me do Pitzer. My computer's really slow today. Okay, so there I have just logged in to the Pitzer shell. I don't like this interface. I feel it's a little clunky, but if you don't have permissions for PuTTY, if you don't like using terminal on the Mac, this is an okay way to get there. So let's turn that off. So I'm going to be going back and forth through this HTML tutorial on OSC and also going on to the actual connection to OSC in the terminal and kind of showing some things around. So first, we're going to start out with understanding where you are when you log into OSC. So the very useful command that will tell you where you are is pwd for present working directory. You can use ls as a command to list the files in your directory or in some other directory. So let's connect to PuTTY. I don't think I can make this bigger. No, I don't know how to make it bigger. Okay, so this, I've just logged into PuTTY and I want to know, where do I start out? So I do pwd, and this says users PAS 1208, and this is my username OSU 0972. So when you first log on to OSC, you are going to be in your own personal project home directory space. And I can't see anything that you make in your own space. So we can look to see what's there. I have a lot of things. You will not have so many things, but this is my own personal working space. Now, when you're doing homework, you need to move into our project space. So let's look into that project space. We ls, and then we were going to use the full path. We do /fs/project. ESS slash PS at PAS 166. What is it? 9. Okay. 1669. What's there? There's a lot of things there. These are from students who've taken this class before, and I just haven't cleaned it out yet. But this is our project space. You know, because it has PAS 1669, and it is not your own personal project space. So let's move into this shared project space. We're not talking about moving it, are we? Okay, so we're just talking about listing. So if you want to see what is in your directory, you use ls. If you want to know what is the directory where you're working at, you use pwd. I mean, I do this a lot just to know where am I, what is here. So keep those commands handy just so you can make sure you are where you think you are. Now, the supercomputer has a directory system, and working on a Windows machine or a Mac machine, you might not be thinking about how your folders are structured, but at the very the very root of OSC is this root directory. It's just a slash. We could go cd slash, and we're at the very beginning of where OSC is. These are things we don't have access to them, but we're at the very top. If you want to, you can go farther. So there's file space, FS. That's going to be all of our shared project workspace. There is user space. So that's going to be your own personal user workspace. And then there's some OSC shared libraries, things that we don't get to touch. So those things are there. So we see here, we see this FS, we see users. Let's go back. What is this directory that when you first log in, you are in a user space. So if you are doing your analyses and you look at your present working directory and it starts with users, you are in the wrong place to work on homework for this class. So make sure whenever you're working for homework for these assignments, make sure you're in the file system, the FS of our project space. So we kind of understand how this space is set up. At the very top, we have our root directory, and then we have different folders in our root directory. We have our file space, we have our user space. So we can go in either one of them. There's also some scratch space. If you want to do something that needs a whole lot of room, you need a lot of storage, you can use the scratch space. And it says here, scratch space is temporary. So if you put anything on the scratch space, it will be deleted within 90 days. So keep that in mind. You need to move anything that you put on the scratch space out to somewhere that is safe, your home space or your project space. Just thinking in your future research if you're using OSC a lot. So think about that. Okay, so now that we're talking about knowing where we are and knowing what is in the place where we are, we can think about moving around. So I'm going to shut this down. Okay, so I'm going to start using PuTTY. I'm going to use OSC. I open my PuTTY. I'm in my project space. I mean, I'm in my user space. When I first log in, I'm in my user space. So I told you, you need to move into the project space before you do anything. So what do we use to move directories? We use CD. So we can do CD, change directory. We have a slash FS slash ESS slash PAS 1669. And this is going to change us in to our class project space. And so there are all of these folders here, directories. You want to call them folders or directories? I don't care. So you can move into a place. Let's say I went into my own directory, CD to Amy Height. That's my folder that I made in our project space. We see where are we? It's this directory set up. So now we are within the Amy Height folder. What is there? I have some things there. I also do your homework, just so I know it works. So I did all of that here. Let's say I wanted to go up one directory. So I wanted to get out of my folder. I'm going to do CD period. And this is telling the environment to go up one level. So if we think about our levels, we are like down here in my Amy Height folder. And now we do CD ... to go up into just the project space. You could also have a series of these. So we go up 1 and up 2. So this is saying we're in PAS 1669. Now we want to go up 2 levels. That takes us to just FS. So we were here in PAS 1669 and we go up 1, 2. And now we're in this file system, file space level. We can look and see what's there with LS. There is ESS folder. There's a scratch folder. Project, something we're going to talk about a little bit later. This project folder is a symbolic link to the ESS folder. So if it's a little bit different color, so that's what it means. So we're going to go back into ESS and PAS 1669. So this change directory, we're moving based on where we are right now. Since I know we're in FS, I don't have to have that FS here at the start. I'm just telling it from where we are in FS, go into ESS, and then go into PAS 1669. And then I can say go into Amy Height. That is me. So I'm going into my own folder again. And now I am back in FS, ESS, PAS 1669, Amy Height. And all of my things are there. Okay, so back to what we're talking about. We talked about moving around using CD. We can use these double periods to go up one directory as many times as you need to. And as you're changing around in directories, use PWD to know where you are. Use LS to see what is there where you are. So always be mindful of where you are in this directory structure. It can get confusing if you are not paying attention to where you are. Okay, so the third important thing we need to talk about is tab completion. So I know we're working in a command line format, so we have to type everything. And that gets really annoying to have to remember how is this spelled, what are all of the things I have to type. So I'm going to go back to my home. This is my personal user directory. I did CD $sign and capital home. So $home is a special variable in this environment, and it refers to my personal user directory. You can use that to stand in for users, PAS, whatever yours is, and your username. It will take you back to there. So let's say we want to move into our project space. So we're going to do CD. We're going to have a slash because we're doing it from the root. And F. I'm just going to type F. And I'm going to do tab. And since in that root directory, the only thing that starts with F is FS, and it fills it in for us. The next thing is tabs twice to see what are the options. I tabbed twice and it told me the options in FS are ESS, project, or scratch. So where do I want to go? I want to go E. I tab again, it fills it in because the only thing that starts with an E is ESS. Now I tab twice. It tells me there are a lot of things to look at. Do we want to print all 912 projects that are present on OSC? We do not. We're going to say no, don't do that. We're going to say PAS and 16. We're going to tab. And when we tab, it's going to show us all of the options of folders at this level that start with PAS 16. And there's a small number of them. I'd say this is 20 or so. And so let's type another 6. We tab twice. I did it too much. Okay, so there are 5 folders here that start out with PAS 166. And I know we need this one that ends with a 9. So we'll just type that and enter. And we are here. So if you are going to type something, we're going to go CD and do something. We know something starts with an A. We double tab, and it tells us all of the options for folders that start with an A. We can type some more, and it knows AM is only my directory. So we're here again. So use tab to your benefit. You don't have to know what the whole folder is spelled as. You just have to know the first few letters, and you can try that tab and usually get to where you're going a little bit faster. So, yeah. If you tap the tab once and it doesn't fill in everything, tap it again and it's going to give you options. If you want to display all the options, there's a lot. It's going to ask you this. You tap Y. If you don't want to see all the options, tap N and type some more. Tab is very useful. Okay. More commands. We are going to see how to use options for our command. So we've already seen LS. We can do LS. What is in this working directory? We can have an option. This is the option -R, capital R. The uppercase or lowercase of letters is very important in a command line environment. LS, capital R, is going to show the recursive LS in all of the different folders. So you see, I have a CLI folder here. I have a hands-on folder. I think DNA-seq is also a folder. So when we do LS-R, it shows me what is in each one of these folders. So I see in DNA-seq, there are some more folders. There's a GATK workshop. There's 1-explore. There's 2-germline. This is showing us that whole file system, like we saw up here, whatever is below where I am. That could be useful if you want to see what is in the folder where I am working. Where is the feature count summary for one particular file that I want to find. This will tell you where it is. So nearly every command in R that you do will have options. If you want to understand all of the options for some command, you ask for the manual. You do man and your command, man ls. And this is the user guide for the ls command. It tells us, it lists the directory contents, and then these are all of the options. Let's see, can we go down? We can go down. Okay, so all of these, there's a lot of options to do whatever you want to do. We're in a special place now. Since we asked for the manual, it's like we opened a file. And it says here, if we want to get out of this, we need to hit the Q to quit. So to get out of this manual, we hit Q to quit, and we're back out to where we can type more commands. So don't get stuck in a manual. Okay, so if we looked at that manual a little more closely, we would have seen there's some options for ls, and it would have explained all of the options. Like here is one with a whole bunch of options. What is it going to do? Okay. So it's doing the L option, the T, R, H, and A options. And you can go on there, read up on your own. What are all of these options doing? Because I don't know, but this is what it prints off for us. It's now telling us some more information about who owns the file, when was this file made, what is the size of the file, what project on OSC does this file belong to? And these letters at the beginning here are all about permissions. They're going to tell what kind of permissions does the owner of the file have? What kind of permissions do other people in the project have? And what kind of permissions do just the general public on OSC have? And there are ways of changing these permissions. That's probably later in our tutorial. Okay, so what we just did, list long format in reverse time order with human readable file sizes of all the files. That's what all of the letters mean. And you can see, instead of having a dash in that option, we just put all those extra options together and it did them all. If you want to do something you've done before, some kind of command that you know is up in your history, you can push the up button to see all of the commands that we've typed so far. You can also, I'm going back down to the end. You can type history. No, you got to spell it right. Spelling is very important. History. And these are all of the commands, the last 1,027 commands that I typed into OSC. Okay. If you've started something, it's running, and you want to stop it from running, you can use Control-C to kill your command from running. Maybe you started running something, you realize it's going to take too long to run. Control-C to kill that command. If you're in your Pitzer shell and you're done for right now, there's nothing else you're going to do, you're going to go have lunch or something, you type exit, hit enter, and it closes your shell. Okay. So that's all about that. We've lost our shell now, though. Okay. Next, we're going to talk about creating things and destroying things. So we're going to go to our class project space. So I just opened a new shell. So where am I? I'm in my user space. I'm going to go cd/fs/. slash E tab PAS 1669. So now we're back to our class project space. What's that next to do? Okay, if you do echo and one of these variables that's in OSC, it's going to print the content of that variable to your screen. So let's check out what is stored in this user variable. No, I didn't spell echo right. Okay, so stored in the user variable is my username. It's going to be your username since you're running it right now. So we've seen, yes, I'm doing this. We're going to make a directory that is named after our username. Here we're using the full path. We don't really have to use the full path. If you just did make directory and this username, it's going to make it wherever you are. But just to make sure it's in our project space, we're going to do make mkdir / fs / ess / pas 1669 / capital user. Enter, and let's see. We just made our directory. Let's see if we can find it. Let's look in the O's. Okay, mine is OSU 0972. So I just made this directory. It's brand new. We can do ls-lh. Okay, and we can see this directory was just made today at 11:44. So that's our new directory we just made. Now we're going to cd into that directory. Do cd OSU 0972. Now we're here. It is empty, but this is my folder in the class project space. We are now going to make a folder called TMP. So we do mkdir TMP. Now we have a new folder. We're going to change into that folder. It is empty, but look where we are. We are in our class project. We are in my username, and we are in the TMP folder. Okay, now we're going to echo some text. And we're going to use this character to send that text into a file. The file's not there yet, so we're going to make this file by running this command. We are going to do echo. We're going to start quotes. Say, hello, bioinformatics, exclamation point, because we're really excited about it. Close those quotes. In this case, you can use single quotes or you can use double quotes, as long as you use the same. And then we're going to send it with this greater than symbol into, what should it be called? First.txt. So we've sent a little bit of text. We're saying echo it into our file. Now we have a new file. What are we going to do with this file? We can cat the file. Cat means concatenate. It will print it out to your screen. Cat. I'm going to tab there. And we print out the contents of our file. If we want to cat, and then we can send it into a new file rather than print it off to the screen. That's why it's called concatenate. We cat first, and we're going to send it into second, txt. What does that look like? We're going to cat second just to see it. So we printed the contents of first 3 times and sent it into a new file called second. And that created the second file. If we wanted to do this again and send more information into second, if we did this right now, just as it is, it would create a new second file. If we want to append more information to an already existing file, we add a second arrow button. You can call it a greater than, or it's an arrow button. I don't know, but we're adding more information while keeping second as it is. And now let's cat second. So now there's 6 of these in there. So think about if you need to make a file and send information to that file, do I want to remake the file over again, or do I want to add more information to it? So we've made our first file, we've made our second file, and we are in our temp directory. But it's a temp directory. These are not very useful files. We've decided we want to delete everything we've done. So we know where we are. We're in the temp directory. We want to go up 1 level. We CD just once. We look at where we are. We know where we are. We are certain this is what we want to do. And we're going to remove this temp directory. So if we try remove directory temp, emp, we get an error because it says we can't remove this directory because there's stuff in there. So what we're going to do first is we're going to remove these 2 files in here. We're going to empty our directory first. And to remove a file, we just use rm. So we rm tmp/first. So this is going to remove our first file. And remember, this is where we are. I'm in OSU 0972. So I have to tell the command line, go into temp, remove this first.txt. And again, go into temp and remove second.txt. So if we look in temp, it's empty. So now let's go back up to our rmdir command so we can remove this directory now. And it worked because it was now empty. So we use mkdir to make a directory, and we use rmdir to remove that directory. If you're just going to remove a file, you can use rm and refer to that file by name. That was that. Okay, so the next thing we're going to talk about is piping and redirection. So we've already seen how to send something that we printed into a file. And I've gotten ahead of myself and I've showed you how to add to a file that's already there. So we're going to test this out. Right. Okay, we're going to make a directory called CLI, and we're going to go into that directory. mkdir CLI. We're going to go into CLI with our CD. It is an empty directory, and now we are inside the CLI directory. We are going to echo some words into this file. Now I am copying pasting. I will encourage you to type the commands out, because sometimes when you copy and paste, you copy extra invisible characters, you don't know where the hair, and then you get into trouble. So always type the commands. It gets a lot to type, but always type the commands. Okay, so we've echoed first into this text file. We've catted the text file. We see what's inside. Now we're going to do the second one. Nope, I didn't get all of it. Okay, next two lines. We've echoed second into the test, and it's overwritten our first text file, and now it only has second within it. If we echo into our test file and we use these double sending characters, I don't know what else to call them, then it's going to append. We look at that, now we have second, and now we have third, because we have appended third into the file that already has second. Okay. Now, so we've talked about these sending characters. The single send will replace, the double send will append. Now we're gonna try we're gonna apply some commands to these text files. What we're gonna do, what does this do? I don't know. Okay. Cuts characters 1 to 3 from every line of this file, test.txt. Okay, so we're using the cut command, the options -C, telling it from 1 to 3. So the first 3 characters from our lines of code. So we're getting SEC and we're getting THI from this file, just printed out onto the screen. Now, if we wanted to do several commands, one after another, and just print the results, we can use this pipe character. We've seen it in our programming as the OR character, but it's, let's see, we're going to cat our tst.txt. It is control pipe. And that will do the up and down pipey line. So do that. And then we're going to cut. Cut -C 1 to 3. So first we're catting the file, and then we're sending it to the command cut. I like to make it very obvious to the command where the thing should be sent, and I add a dash here. I think in the examples we don't have a dash because it's obvious. It needs to be at the end, so we don't need that. Okay, so we accomplish the same thing. We do 2 different commands. So we've done this. So this up and down line is a pipe, and it takes the results of one command and sends it to the next command. And then we're taking the results from this command, run on what we found back here. We're going to pipe it to this sort command, and it's going to sort it with the -R version, which means reverse. So let's try that first. And copy and paste. I'm just going to type it. Okay, we're going to go up. We're going to add another pipe. We're going to sort -R. So this is going to sort it alphabetically in reverse order. So THI is first now. We're going to add something else. We're going to take the results of our sort. We're going to pipe it into this grep function. And grep is a way of searching for pattern matches. We're going to look for lines of our output, grep them. It's a verb now. We're going to grep for any line that contains an S. So let's put the up button. We're going to add another pipe. We're going to grep S, just the letter S. And now we have found the line of our text file that has an S. So it's a great way to set up your operations and see the output of each step. Well, if you don't care about the output. Okay, so just send the results of one command to another command. And you don't have to really care about the intermediate options. Sometimes I will do something like, tell me my history, but I don't want to print out all 1,000 lines. I will pipe and tell it tail. Give me the last few lines of my history. You can do the same thing with head to get the first few lines of my history. All right. So we're going to talk about this last section, and then we're going to take a break and come back and talk about more of this tutorial. Okay, so compression and archives. So if you've ever zipped up a folder on your laptop, that is a way of compressing larger files into a smaller format. When we work in a Linux command line environment, we use gzip a lot. So let's see, what do we have here in our directory? We have a test file. So we're going to let's look at how big is test? It is 13 kilobases. Okay, so we are going to gzip test.txt. You see, it is gzip now. How big is it? Okay, so I don't know. It's now slightly bigger, but it should have compressed it. I think because it's so small that the actual gzipping of it makes it a little bigger. But in any other situation, zipping this file would make it smaller. And it turns it into a binary format. We cannot cat this anymore because it is packaged. It's just garbly goop. So if we wanted to look inside of our folder without unzipping it, we could use zcat. Zcat test, and now we see inside of it, but it stayed gzipped. If we wanted to uncompress it, then we do junzip. You gzip it to zip it up, you junzip it to unpack it. So junzip test, and now it's unpacked. We can cat it again. Okay. So you zip up big files to make them smaller. You unzip big files so you can actually use them. Sometimes you're going to need to download files from somewhere else. And as long as there is a URL that you can get, you can download directly into the Linux environment. You can use wget. So let's do that. I have to copy this. I can't get around it in any. That's close enough. Okay. So I copy and paste all of this or type it. I do recommend always typing things. This is a long URL. So if it works to copy and paste, that is great. What we have done is we have downloaded the FASTA formatted sequence file of chromosome 22 from the UCSC genome browser. This is build HG38. And we use a command called wget. So this is a way of downloading from a link, wget. And so what did we download? We downloaded a gzip file. We can't really look at it right now, but we can unzip it with junzip. Chromosome 22. Now it's there. We can look inside of it with head. And let's look at the tail end of it. It's all ends at the beginning. It's all ends at the end. Okay. But we will look inside of it more later. So we did the wget, we did the junzip. to be able to look inside of it. You can also use this curl command. It does the same thing to download the file. And in this instance, we are piping that to our GenZip and sending it to this chromosome 22.fa directly. So instead of using two commands here, we could use this curl command. Let's see if my computer lets me copy. No, we can't. Let's see. Okay, we can highlight it over this way. Okay, so if we just paste this command, it's going to download it, it's going to unzip it, and it's going to save it into this chromosome 22.fa. It's going to write over the one we already have. It made pretty fast. So that is what we have. We have a chromosome 22 FASTA that we're going to use in the second part of this lecture.